For year 11 methods, we're going to look at the last year's chapter 3 tests. So this is the tech 3 section, all done by hand. You should be quick because you got 60 marks for 50 minutes. Okay, first question, factorize the following. So that's a dots pattern, not factorize, expand the following. It's a dots pattern. So first term squared minus second term squared. So 4 squared minus 9, so it's B. Question 2 can be root when fully factorized, it can be written as. So I need to take the factor of 2 out because they all go into 2 minus 3x plus 2, and I need to factorize inside using hopefully cross products. 2, 1, they're both negative. So we've got 2x plus 2, x plus 1. That's 1, that's done. Question 3, we want to find x-intercepts. So x-intercepts means that equals 0. Use null factor law, so either x equals negative 3 over 2 or x equals 5. So the answer should be A. Question 4, we want to write that in turning point form. So I want to write in turning point form, so I got to change that to scaffold form. X minus 3 minus 9 plus 1, so we get x minus 3 squared minus 8, because when I add 1 to negative 9, I get negative 8. So answer C. The discriminant, okay, discriminant's b squared minus 4ac, b 4 squared, 16 minus 4ac, that's a plus, 3 fours are 12, 12 times 2 is 24, so 24 plus 16 gives you 40. D. Question 6, the y-intercept, when you sub in x equals 0, so 5 squared minus 3 equals 25 minus 3, which equals 22. So answer is A. Question 7, the number and nature of the solutions. Okay, so it's asking for the discriminant. So a squared minus 4ac, negative 3 squared is 9, minus 4 times 2 times negative 2. So it's 9 plus 4 times 2, so 16. 25, that's a square number, so you'll get 2 solutions, but they'll be both rational. Question 8, the quantum turning point for the parabola of the equation is, so you need to know that y equals x squared has gone skinnier, and then the skinny parabola has been moved up 9. So what's happening here? Original parabola, skinnier, then moved up 9. So skinnier moved up 9. So it's at the one at 0, 9. So easy answer. Question 11, expand and simplify the following. So I like to expand this part first. So this becomes 6x minus 3. Then the second bracket didn't disappear, so you need to multiply the first result with the second one. So we'll get 6 fours are 24x squared plus 18x minus 12x minus 9. Simplify. That's 18x minus 12x is 6x minus 9. Next one, that's a dots pattern. So we go 16 minus 9a squared. I expand this as a perfect square. So negative first term squared. First term times second term. So a times negative 2 root 3 is negative 2 root 3a. Double that. So negative 4 root 3a. And then I square the second term, which is negative 2 root 3 squared is the same as 4 times 3, which is positive 12. Let's expand the bracket. So all the signs change. And I'm left with negative 10a squared plus 4 root 3a. 16 minus 12 is plus 4. Okay. Factorize the following. They both go into 7km. Left with a k minus 3m, like that. This one's a dots pattern, so it's 4 minus a plus 2. Remember, put the brackets in because you've got a negative there. for a plus 2. Now, I don't need to put brackets because they're all pluses. Okay. Now, 4 minus a minus 2. 4 plus a plus 2. So 4 minus 2 is 2 minus a. 4 plus 2 is 6 plus a. Okay. Next one, there's no common factor, so I'm hoping it's a non-monic cross product. 6, 1, 1, 6, 2, 3, 3, 2. Let's see which one works. 2 times 1 and a 6 won't, 2 and a 6 won't work. 2 times 6, so 2 times 6, 12, 12 and 1. Does it give you 11? Yes, it could. If I have positive 12 and negative 1. Okay, so 2x minus 1, x plus 6. Remember to show it working, please. Else, if you get it wrong, I can't give you the mark at all. That's worth 2 marks. Next one, factorize by completing the square. So I'm using the scaffold. This is this doesn't have a coefficient of front except for 1, so it's good. I can use scaffold straight away. So -5, 25 minus 3. So x minus 5 squared minus 28. Now I'm going to use dots because it says factorize the following by first completing square. So factorize means put it in brackets. So x minus 5 minus root 28, x minus 5 plus root 28. Now, root 28 can be simplified as third because root 28 is same as 4 times 7. That's a square number. That's great. You can take it out. 2 root 7. So x minus 5 minus 2 root 7. X minus 5 plus 2 root 7. Now, as a method student, I am expecting you to simplify all your surds. Okay, so don't leave that as root 28, please. Part B. Now, there's a number at the front of the x squared, so I need to take it out before I use complete the square. Okay, now I can factorize. I can't use cross product because there's no number that multiplies gives you -1, but add to give you -3. So I have to use complete the square. So scaffold inside. X minus 3 over 2 minus 9 over 4 plus 1. So if I put 1 over 4, 1 as being a number over 4 will be 4 over 4. So 4 over 4 minus 9 over 4 is minus 5 over 4. Simplifies that. So I expand the bracket so that I can put the 2 inside, back inside. So 2 times the bracket is just 2 times the bracket. 2 times -5 of 4 is actually no, wrong method because I'm trying to factorize. So I'll just use dots inside. So dots here. So go 2 x minus 3 over 2 minus root 5 over 2 x minus root 3 over 2 x minus 3 over 2, sorry, not root 3 over 2 square root 5 over 2, like that. Okay. Yeah, you can leave in that form. That should be fine. Question 14. Solve each of these following equations. So I can move the 36 to the other side. I divide both sides by 4 to get 9. X equals plus or minus 3. Next one, 3x squared plus 2x minus 21 equals 0. I want to move all the terms to one side. Then hopefully I can factorize this using non-monic cross products. So 7, 3, 3, 7. Let's check if these ones work. 9 and 7. Yes, that actually gives you a one that works. You need to tweak it. So what? Positive 9. Whoops, positive 9, -7. Okay, so that works. So 3x minus 7, x plus 3 equals 0. So x equals 7 over 3 or -3. The next one, I can't factorize this using cross product. So the easiest way to get the solution is to complete the square. We need to draw the graph of it. We know it's a smiley face, but we need to know where the x-intercepts are before I can work out where it's positive. Okay, where the whole graph is positive. So I need to get a solution. So I'm going to use the quadratic formula. Negative b plus or minus b squared minus 4ac over 2a. So negative b, -5, -5 is positive 5. B squared 25 minus 4 times 1 times -2 over 2a, which is just 2. 5 plus or minus 25 plus 8 is 33 over 2. Okay, so I got my two x intercepts. So I'm just going to rub this out. I'll draw it over here. So we got our two solutions. 5 minus root 33 over 2. 5 plus root 33 over 2. Where's the graph positive? Let's look. Well, the y is positive here. So that's what we want. When does that occur for your x? So x will be less than x will be no, oops, x will be less than 5 minus root 33 over 2, but or x will be greater than here. So it's here and there. X will be greater than 5 plus root 33 over 2. Okay, so those are your two solutions because we want the graph to be greater than 0. Okay, that's when it's greater than 0. Sketch the graph of these ones. So I want to sketch the graph. Now this is in TP form already, so I can read the TP. TP would be given by -1, 2. My shape is a smiley face. My y-intercepts, I sub in x equals 0, so 5, 1 squared plus 2. 5 plus 2 is 7. Okay, great. And my x-intercepts. Now, before I even go checking x-intercept, I need to be smart here. So my turning point's at -1, 2, and my y-intercept's at 7. So I'm just going to put 7. Maybe I put, okay, you got to make it proportional. So if I put -1, 2 here, y7 would make sense because it's somewhere over here. Now I can see already the graph is not going to have a x-intercept, so it's going to look something like this. Okay, it's going to look something like this. Okay, so make sure you label all your points, and we're happy. Okay, now I'm drawing this on the computer, so it's harder to draw, but make sure you're relatively detailed and accurate with that. Okay. Part B, I want to draw this graph. So y-intercept 0, -12. I always want to put I want to find the easiest features. So smiley face. I can get the turning point using by a scaffold or completing the square, so I can do that. Or I can find the x-intercept first. So I'll try to find the x-intercept first. So y0, 0 equals x squared plus 4x minus 12. Cross product, hopefully works. 6, 2, yeah, work. Minus 2. So x plus 6, x minus 2 equals 0. Let's check if that's correct or not. So, yep, that works. So, our x-intercepts are at -6, +2. Okay, -6, +2. Our TP, XTP would be the average of x-intercepts, so -2 plus 2 divided by 2. That's -4 divided by 2 is with -2. YTP would be when we sub in the value of -2 into the original. So 4 minus 8 minus 12, which gives you -20 plus 4 is -16. So TP is at -2, -16. Okay, so -2, -16. Y-intercepts at -12. Okay, that makes sense. So -2, -16 we'll say is around here. -2, -16. My y-intercepts at -12, and my x-intercepts at 2, and so 2 and -6. So 1, 2, 3, 4, 5, 6. 2, -6. Okay, that makes sense. So we got a graph. Looks something like this. Okay, again, try to be symmetrical as possible. This would be 0, this would be your -12. Okay, and make sure you label everything. Okay, -6. I've labeled everything, and this is pretty accurate. Also, don't forget, read the question. What does it say in the question? So, all intercepts, axis of symmetry. Okay, that's what we're forgetting. So, axis of symmetry on the first question will be just the x coordinate of your turning point. So, x equals -1, x equals -2. Lastly, we want to draw the graph of this. So, um, there's no two numbers that multiply to give you 3 and add to give you -6. So, I'm inclined to use the turning point method. So change the turning point form. So y-intercepts at 0, 3. Our shape is smiley face. Our turning points, I'm going to use scaffold. So x minus 3 minus 9 plus 3. So that becomes x minus 3 squared minus 6. So TP is at positive 3, -6. Okay, to get the x-intercepts, all I need to do is I let that equal 0. So 0 equals x minus 3 squared minus 6. Moves the 6 to the other side. X minus 3 squared. Square root both sides. X minus 3. Add 3 to both sides. So 3 plus minus root 6 would be my turning points. Now, because root 6 is less than 3, they're both going to be positive. Okay, they're both going to be positive region. So we've got two x-intercepts, both are going to be positive, and my TP is 3, -6, and my y-intercepts at 3. Okay, so it's going to look something like this. So that's your y-intercept. Your TP is twice as deep compared to y-intercept. So it's going to look something like this. So you're going to label your y-intercept, which is at 3, 3 minus root 6, 3 plus root 6, and your TP is at 3, -6. Axis of symmetry would be x equals 3. Okay, so don't neglect all the features because you'll lose marks if you don't. Okay, give your answers exact. That's what it means by exact. Okay, so that's your final graph. Question 16. Find the rule for the parabola with y equals a plus 6 squared if it passes through -3, 12. Okay, so -3, 12. Okay, so all I need to do is sub in. So 12 equals a -3 squared. 12 equals 9a. A equals 12 on 9, which is 4 over 3. Okay, 4 over 3. That's your a value. Double check that you've done everything right. Yep, I just subbed it in and I solved for a. Determine the equation, and you need to simplify fraction skills. Okay, you are a method, so I am expecting you to know how to do it. So next question, determine the equation of the parabola shown on the right. Okay, so I can use, I know two x-intercepts, so I'm going to use factor form. So y equals a, x minus b, x minus c. I know my first factor will be x plus 1 and x minus 3 for the second factor. I just need to sub in -6, 2. So -6, 2, sub in, -6 equals 2 plus 1, 2 minus 3. So -6 equals a by 3 minus 1. -6 equals -3a, a equals 2. So therefore your equation is y equals 2, x plus 1, x minus 3. Done. Question 17. Write an expression for the discriminant in terms of k. So discriminant equals b squared minus 4ac. So 7 squared, negative 7 squared is 49, minus 4 times k times negative 1. So that equals 49 plus 4k. So determine the values for k for which there will be two solutions. So we want 49 plus 4k. So we want discriminant, two solutions mean discriminant greater than 0, so we want that to be greater than 0. Solve it, so I move the 49 to the other side and divide both sides by 4. So k has to be greater than 49 over 4. Done. Question 18. Calculate the coordinates of the intersection between this and that. Intersection means you let y equal to y. So you go 2x plus 3 equals x squared plus 7x minus 11. I want to move all the terms to one side, so I'm going to move all these terms to that side. X squared, 7x minus 2x is 5x. Minus 11 minus 3 is minus 14. Hopefully we can factorize this using cross method. So 7 and 2, yep, they'll work. 7 and 2, but we'll have negative 2. So x plus 7, x minus 2 equals 0. And we've got x equals negative 7 and positive 2. Now that's just the x coordinate, okay? To get the y coordinate, you just sub in. So negative 7 squared, when we sub back into the y, we get 49 minus 7 sevens are 49 plus minus 49 minus 11. Okay, so that gives you, they cancel, so you're left with negative 11. And when you sub in 2, you get 4 plus 14 minus 11. That's 18 minus 11, so you get 7. Okay, so you get two coordinates of points of intersection will be negative 7, negative 11, and 2, 7. So those are your two coordinates. You need to make sure you write the y coordinate to get the full marks, because last year not everyone did. Show algebraically that a parabola that and that never meet. Okay, so let y equal to y. You're just basically finding the discriminant of when you let y equal to y. So move all the terms to one side. So that's negative 2x plus 2 equals 0. Discriminant will be b squared, 4 minus 4ac. So 4 minus 4 4s are 16 minus 16, so that's minus 12. Since discriminant's less than 0, they will never meet. So no solution. Okay. So that's the whole of the paper. So hopefully that gives you an idea how to approach this. If you need to pause at any time, make sure you do.